All right, folks, number two. So number two, simplifying square roots. I'll be pretty quick with this. We went over A in pretty much every class that I can remember, okay? When you're dealing with the square root, you're going to break it into its prime factors, and you're then looking for perfect squares. So actually, you know what? Let me take a look at A. I came up with something. Hopefully you guys can see this. Hopefully you get a chance to see this. I was doing some work with somebody today, and they came up with a pretty good way to write it. So real quick, just to recap, so everybody should have this. When you start to break it down, and so I'm not going to get into it too hard in terms of how to, what to do. I'll do that on the next example. Once you're done breaking it down, okay, and you get your prime numbers, and you write it all under a square root, like this, what you can do is, we're looking for perfect squares, right? Or pairs. Same thing. This pair represents a perfect square. So what if I rewrite it like this? I'm going to put it back together, actually. We never really wrote it like this in class, but this makes a lot of sense. Square root of 3 times 3 is the square root of 9. That right there is a perfect square. That's why it leaves. That's why square root of 9 is 3, and the square root of 13 stays underneath. That's why we say a pair leaves, because 3 times 3 is 9. The square root of 9 is 3. So this is a different way to rewrite it. So that's pretty cool. I kind of like that. Somebody showed me that. They tried that, and I thought that was a pretty good idea. All right. So we can even look at it here the same way. All right. Now, the other thing to mention here is once this number's out, square root of 9 is actually the number 3. Once it's out, it's the number 3. It's out there. Square root of 13, that's not 13. Square root of 13 is 3 something, 3 point something. All right. So when you're looking at this is the number 3. It's on the outside. It's not going to really have an effect on the square root of 50, anything on the inside. So this one, just kind of ignore it for now. We can bring it down to the bottom. And we'll deal with it. And by the way, it's multiplication in between 3 and the square root of 50. So we'll put a multiplication symbol there. But let's break apart 50. The most popular one would probably be 2 and 25. All right, that's 2 is prime. 25 can be broken into 5 and 5. All right, and those are both prime. Okay, so under the square root is going to be, let's do 2 times 5 times 5. The order doesn't really matter. In fact, let me rewrite it up here as, let's put the pairs first. Order doesn't really matter, it's multiplication. But underneath, you have 5 times 5 times 2, all right? There we go, focused up. All right. 3 again, still on the outside. Nothing's going to affect it. It's not going to affect anything on the inside, but that square root of 5 is a pair. In fact, you can rewrite it as square root of 25 if you want. The square root of 25 is 5, the number 5. So it's going to be 3, 5, and then the square root of 2 is still underneath. Now that square root of 25 became the number 5. It's on the outside with the 3, and everything's being multiplied, so numbers multiply like numbers. The answer is 15 square root of 2. All right? We're looking for perfect squares. We find it with the pair of 5s, and you don't have to write it like this. Just an idea. So then you can see it becomes the 5 on the outside, multiply, 2 still trapped underneath. All right? All right, guys, take care.